Hi y'all, and welcome to lesson 1-12, which is all about multiplying and dividing radicals. By the end of this lesson, our objective is that you should be able to multiply and divide radicals and express their answer in simplest form. If you have not located this lesson in your notebook as yet, please do so. Alright, so let's get started. The first and most important thing that you need to know is that you do not need to have the same radicand in order to multiply and divide radicals. Please ensure that your notes look exactly like my notes. Now that we've established that we don't need the same radicands, let's talk about how to multiply radicals. The first thing that I'm going to do is multiply any coefficients if they are given. And as you know, if there's no coefficient, you can always place an imaginary one in front. The second thing that you'll do is multiply your radicands. Again, remember that they do not need to be the same in order to do this. And then last but not least, you will simplify if necessary. Again, please ensure that your notes look exactly like my notes. Now let's take a look at the first example. I see that I have root 6 multiplied by root 6. In this example, the radicands happen to be the same, but they don't have to be. I do see a multiplication symbol, so that means I'm going to multiply 6 times 6, which gives me a product of 36. And then I'm going to simplify, because the square root of 36 is equal to 6. Moving on to our next example. I see I have root 5 multiplied by negative 4 root 20. In this example, I have a coefficient of negative 4. However, root 5 does not have a coefficient. If I'm so inclined, I could put an imaginary 1 in front so that it now has a coefficient. Step 1 is to multiply my coefficients. So 1 times negative 4 is negative 4. And then I'll multiply my radicands. 5 times 20 gives me 100. I can then go ahead and simplify, and this will rewrite to negative 4 multiplied by the square root of 100 is 10. And negative 4 times 10 gives me a product of negative 40. As a pleasant reminder, please ensure that your notes look exactly like my notes. And let's move on to our last example for multiplication. And I see I have 3 root 12 multiplied by root 6. That dot there in front of the paper is just a printing error. So again, root 6 doesn't have a coefficient, so I can place an imaginary 1. And I'm going to multiply my coefficients of 3 times 1, which gives me a value of 3. And then I will multiply my radicands. So root 12 multiplied by root 6 gives me root 72. At this point, I know that my answer is not in simplest terms because there are perfect squares that evenly divide into root 72. I'm going to choose to break this down into root 9 multiplied by root 8. Once I've broken it down, I'll then carry down my coefficient of 3. The square root of 9 simplifies to be 3. And I don't know what root 8 is, so I'm going to carry that back. And I carry down my coefficient. So now 3 times 3 is 9, root 8. However, at this point, I do have to ask myself a question: is this in simplest terms? And it is not, because there is a perfect square that evenly divides into root 8. So you'll see me breaking this down again into root 4 times root 2. The square root of 4 is 2 times root 2. So my final answer is 18 root 2. My challenge to you is, what was the largest perfect square that I could have used to evenly divide into 72 instead of having to reduce 2 times in order to get my radicand in simplest form? If you have determined that I could have broken down root 72 by 36 and 2, you'd be absolutely correct. Because the square root of 36 is 6, and then I would have multiplied by my coefficient. Alright, so let's move on to our examples for dividing radicals. The first thing that you will need to do is to divide your coefficients if they are given. Step 2 is to divide your radicands, and step 3 is to simplify if necessary. Please go ahead and make sure that your notes look exactly like my notes. Alright, so let's complete our first example. We see that we have root 48 divided by root 2. In this case, I have no coefficients, so I'm good, and now I'm just going to go ahead and divide my radicands. Root 2 divides into root 48 24 times. Now that I have root 24, I do need to simplify this, so I'm going to check for the largest perfect square that evenly divides into 24. That perfect square is 4, and that would be multiplied by 6. The square root of 4 is 2, and root 6 does not have a perfect square, so therefore I'm just going to rewrite my final answer as 2 root 6. Again, please make sure that your notes look exactly like mine. Our next example is 25 root 24 divided by 5 root 2. In this case, I do have coefficients of 25 and 5. 5 evenly divides into 25 5 times. Root 2 evenly divides into root 24 root 12 times. And then I will need to simplify my answer. I know that root 12 is not in simplest form, so I'll have to break this down into the product of root 4 multiplied by root 3. And I've also brought down my coefficient. Again, I'll carry down my coefficient of 5. The square root of 4 simplifies to be 2. And then again, root 3 is not perfect, so I'll carry that down. I'm then going to multiply 5 times 2, and I get a final answer of 10 root 3. Alright, so let's do our last example. We have root 9 divided by root 25. In this case, both of these happen to both be perfect squares. The square root of 9 is 3. The square root of 25 is 5. And then I come out with the answer of 3 divided by 5. And this fraction is also in simplest terms, so I'm done right here. Thanks for riding along in this journey of learning how to multiply and divide radicals. Your task is now to complete the student page. It is only one, and it looks like this. Again, please remember that you do need to show all of your work. Final answers alone will never, ever, ever be accepted. Final answers alone will receive no credit. If you have any questions or need any assistance, please make sure that you turn to each other, turn to your notes, and definitely please ask the teacher in the room. Happy mathing, guys!